Thank you, Jamie. This particular topic is near and dear to my heart because I was involved in two different NRC reports, and many of the data and conclusions emanate, at least inspired by these two reports. Water implications of biofuels production in the United States, which I think has a 2008 date on it, and renewable fuel standard, potential economic and environmental effects of U.S. biofuel policy. So as Jamie said, I'll try to concentrate a little bit on the quantity, availability side of the water and biofuels question. Most of the health effects are kind of indirect. Perhaps in discussion we can draw those out a little bit, but I hope they're certainly related, though I'm mostly talking about quantity issues related to biofuels of water. There's at least two main ones which I'll hit on. I won't do everything which is on this slide, but the impacts of growing the crops on water quantity. How much water does it take to grow the feedstocks for biofuels? And secondly, the impacts of ethanol production facilities themselves. How much water does it take to produce the biofuel for industry? And we will talk a little bit about maybe what does the future hold. Some people would say that to make the mandate that we're all talking about, it's easier to get for a camel to get through the eye of a needle. But more on that as we go along. But the Energy Independence and Security Act, as you know, requires 36 billion gallons of biofuels of various sorts to be delivered by 2022. And there are difficulties with doing that, water issues included in that. If we were just to look at, in a chart format, the RFS2 mandate, you can see that for the most part, we're already going very close to the 2015 portfolio of biofuels being produced. We're around 14 conventional billion gallons per year these are in of conventional biofuels. But EPA has the ability, has the call to year by year change this particular formula, and already they've changed the cellulosic biofuels, which were supposed to be 400 million, 0.4 billion gallons per year in 2010. We weren't able to make that. In fact, we're something like about, I don't know, 25,000 gallons currently, so we're well below that. And that calls into question, I guess, the future, especially for the bottom line. Trading with Brazil, which has been much talked about here, could provide some of the advanced biofuels as it's presently determined, but the cellulosic biofuels component of the mix seems the most in jeopardy, and probably many would say you can argue that it's an economic problem, that the cellulosic biofuels cost too much, or you could argue that it's a technological problem, that we really haven't had the breakthrough in technology that's necessary to produce those cellulosic biofuels. But it's really two sides of the same coin. It's both. We're not able to produce those biofuels yet. In fact, in the fermentation process of cellulosic enzyme, the enzymes alone are costing on the order of more than $1 a gallon, and we're trying to produce the fuel for roughly $1.50 per gallon. So we're quite far away from a commercial cellulosic biofuel, I'm sorry to say. And what's more, as we shall see, if you're going to achieve these kind of numbers, even in 2015 and 2020 and 2022 for cellulosic, you would have to have the plants built today. So we'd be completing and finishing out the construction of the plants for the cellulosic ethanol today in order to make that. So it's virtually assured that there's no way that we're going to make that portion, the 16 billion gallons of the 36 billion gallon total. You know, I come from Iowa, so I'm completely biased on this question, but corn is a pretty amazing grain, actually. You can do an awful lot with a bushel of corn. You can turn it into starch. It is a starch grain. That's why we use it for ethanol. You can make corn sweetener, and we do some of that, and all the health ramifications there that we can talk about. You can make ethanol, roughly about 2.8 gallons of ethanol, and it's got some nice byproducts. And the byproducts are important because they can be fed to animals also, making back some fraction, maybe up to 1/3 of the original feed value for animals in the byproducts. And of course, it is a job creator for a smaller plant of 50 million gallons per year production facilities, maybe 40 permanent jobs. And when you multiply that by hundreds of plants, it starts to make a significant number of jobs. As you know, and has been talked about already today, the tax credit for blenders of corn ethanol, conventional biofuel, has expired as of last year, but biodiesel and cellulosic ethanol still does enjoy a substantial tax credit of $1.01 per gallon. I have to keep changing these numbers. I apologize. I originally got the slide from Nicole Fuller at National Science Foundation, but how we're using our corn is changing. We're up now to using about 40% of the corn production in the United States for ethanol fuel right now, a very substantial fraction. In Iowa, in fact, it's much more than that, maybe 2/3 or even 3/4. There's talk about if corn-based ethanol were to continue to expand, Iowa would have to become a corn importing state in order to feed its animals. That's what a big industry the ethanol industry has become. Last year, I think it was, maybe Kathy knows, for the first time, the ethanol feedstock surpassed animal feed for the first time. So we're really into substantial territory. And of course, it can be used for many other things, as we talked about earlier. The corn yield, many people in the industry say, industrialists will say, well, really the food versus fuel is not such a big issue because they're expecting such large increases in yields, and that the increased yield on a given acre of land would make up for that capacity that's needed to produce the fuel. But I'm sorry to say, I don't think the figures, at least so far, bear that out. We are increasing yields quite nicely. The GMO crops are doing quite well in terms of yield in general. We're getting about 2 bushels per acre per year more corn yield from an acre each year until you can see the drought of last year. And this is, of course, a hazard with, it's a bit like a cartel where you can't always depend on your fuel supply. If we have a drought or a flood, you can't always depend on your feedstock supply either. And that's what happened in 2012, and we dropped down to about 123 bushels per acre. Well, coming to the quantity of water that's required to produce this biofuel, we can use so-called green water from rain-fed agriculture. The Midwest is mostly blessed with rain-fed agriculture, which comes from just natural precipitation and used by the crop. Or you can use so-called blue water from streams or from groundwater to irrigate the crop, and that's what's kind of depicted on this particular slide. The crop might use roughly the same amount of water either way, but if it comes from precipitation, say, as opposed to from a groundwater supply that might be being depleted, there's real sustainability issues involved with the irrigation of that crop. Most of the plants are shown in blue dots here from a USDA slide, and you can see that mostly this is rain-fed agriculture. Mostly this in the West is irrigated agriculture. And again, the crops use roughly the same amount of water, but if you're irrigating, it might come from a limited supply. And that would be the case in California in the Central Valley, where you might need 4,000 gallons of water per bushel of feedstock, in this case corn, or in the High Plains or the Ogallala aquifer of Nebraska, where you might need 2,000 gallons of water per bushel of corn. And that would be, of course, an issue with drawing down these aquifers, the Ogallala, as a result of that irrigation. This is a similar slide, only it shows the aquifers here, the High Plains aquifer, and the size of the dots are how big the production facility is. The larger the dot, the larger the production facility. And I use this slide to mention that it's not only the irrigation of the feedstock that's an issue for the quantity of water, but it's also the quantity of water needed for the production facility. And even in the rain-fed Midwest, they need high purity water for these black dots for these production facilities. And they're largely taking it from, and that high purity water is largely taken from confined aquifers. So they're, I would say, unsustainably pumping down the aquifers in order to make this. Now, any industry would have a water requirement, and any industry that has a large water requirement would be permitted to do the same thing. But the point is that with a concentration in a given geographic locale, that's how you can begin to really impact the resource. In this case, a confined aquifer under pressure. In Iowa, for example, we have quite a few ethanol production facilities, and the Silurian Devonian aquifer, and even more so the Cambrian Ordovician aquifer, it's called the Jordan aquifer, has been pumped down 150 or 200 feet. So eventually you won't be, future generations wouldn't be able to use that aquifer. It does recharge, but it recharges over a much longer time scale than would be of interest to our commerce and humans. Just a note about water quality. If you are using corn, the conventional biofuels, or even soybeans for soy diesel, these require a lot greater inputs. These are high input feedstocks, high input crops that require a lot of fertilizers and a lot of pesticides. And the hope is that the cellulosic biofuels would require much less, even though we don't have any commercial facilities yet in operation, but that they would have some real benefits in terms of especially water quality and to some extent water quantity as well. The problem with all of that high input agriculture is that while it is true that the total acreage of land in the United States committed to agriculture has not increased in recent decades, it's been roughly constant, still the fraction devoted to corn has been increased. We're near record devotion of acres to corn right now, and that means more and more inputs, and therefore it means more and more impact on water quality. And in this case, it's not only visited on the states where that enjoy the ethanol production facilities, but it goes down the Mississippi River to the Gulf of Mexico. And we'll hear more about that, I'm sure, from Kathy Kling. I wanted to show you just a kind of typical conventional biofuel plant. This is in the center of the state, Lincoln Way Energy Plant, 50 million gallons per year, nice sunny skies, so you can see that life is good. But to give you some idea, this is using about 18 million bushels of corn per year and about 200 million gallons of water per year. The older facilities like this one are averaging about 4 gallons of water per gallon of ethanol produced. The newer facilities can get down to maybe 2.5 or even 3 gallons of, they're more efficient and they're becoming always more and more efficient. But it is an intensive industry from the standpoint of producing the ethanol at the production facility. Again, usually these plants would be pumping up groundwater for the high purity water that's necessary to make the bugs happy in the fermentation, hydrolysis and fermentation processes. A production facility for 100 million gallon per year corn to ethanol plant would use something like 300 or 400 million gallons of water, and that's roughly equivalent to a town of 5,000. So for every blue or black dot on those previous maps, you can think of a new town springing up with water needs of roughly for 5,000 people. So it is a pretty intensive industry in terms of water. Now, cellulosic ethanol could come from corn, but it also could come from corn, I should say corn stover, from wood waste, or from dedicated bioenergy crops, some of which are shown here. And we need that to amount to 16 billion gallons per year. But and there are plants being constructed now. In our committee, we liked to joke, maybe you've heard it, that the cellulosic ethanol is just 5 years away, and it always has been and it always will be 5 years away. And that's sort of the place where we stand today as well. There's other questions that you can imagine with the delivery of this diffuse, light, fluffy materials. Here's corn stover is shown. Maybe you would bale it. Maybe you'd roll it like this and transport it to the ethanol production facility. The one I showed you, the pretty one at Lincoln Way Energy Facility, is using all the corn in the vicinity, about 100,000 acres of corn, just for that 50 million gallon production facility. The beauty of the corn stover would be at the same facility, you would begin to process cellulosic ethanol from one pass through the field in taking the corn stover. But you've got to get it there, you've got to harvest it, you've got to preserve it. You need it all year long. You're only going to get it one time a year. So there's lots of questions, including the question of how much can you take. Most studies indicate that you could take at least 50% of it as long as the land isn't too sloped. And the new GM crops produce much more. They're planted much closer together, and they're producing actually so much stover, so much residue that you would almost have to remove some. And that, of course, means you have to replace the nutrients, the nitrogen, from all that stover also, so you have to put on more and more nutrients as a result. We have two plants under construction, cellulosic ethanol in Iowa. One is by DuPont. I think they intend to use switchgrass. One is the Poet DSM, that's a Dutch company, I believe, Advanced Biofuels, and this is the existing corn ethanol plant at Emmitsburg, Iowa, in the grainy image here. But right next door, they'll have, right at the same location, a 40 million gallon per year cellulosic ethanol that would use, originally it was corn cobs, but they are having some trouble with that. It looks like maybe corn stover at this particular facility, and it is under construction. David Tilman, Jason Hill, and others have suggested that, gee, maybe, especially if you go with thermochemical processes, that you could use mixed prairie grasses. Certainly you should be able to use switchgrass for cellulosic ethanol, and that maybe the hope is that this would give higher yields with lower water inputs and lower nutrient and energy inputs as well, lower greenhouse gas emissions as well. That would be a much better system. But I must say that we have very little experience with this. I have some feeling that we'll tend to fertilize much more, maybe irrigate more than one might think when they're doing the life cycle assessment. So the truth is we don't have much experience, but we need to gain experience if this is going to be an important component of the portfolio for biofuels. Of course, dedicated energy crops will likely be important too. The ones most frequently mentioned are poplars and willow, in addition to the switchgrass mentioned earlier, miscanthus. Southern pine could be utilized, and the wood products industry really needs a kickstart right now, and some people have hopes for that. You may know that there have been 2 studies by DOE, the most recent one, the so-called billion-ton study, that asked the simple question, can we grow enough biomass with existing land for all these needs, both waste to energy and for biofuels? And the answer is probably yes. This map would indicate 500 or 600 million tons per year from corn, stover, dedicated energy crops, and forest residue. Certainly the southeastern United States with wood products would be a source of both wood waste and a lot of products for making cellulosic ethanol. Almost my last slide is probably among economists on our NRC committee. This was most important to them, showing the problem that we're up against with cellulosic ethanol, that there's such a disparity, such a gap between the willingness to accept payment and the willingness to pay from suppliers. So the suppliers would be the farmer, for example, and the production facility would have to pay that amount, and they're quite far off. As you can see, the willingness to accept is in the order of $75 to $100, and the willingness to pay is only $25, so we're really quite far off from having a meeting of the minds and a commercial venture here, according to this particular survey. So corn ethanol production is peaking under RFS2. We're almost at the 15 billion gallons now. Iowa alone is making about 3.7 billion gallons per year. Iowa is projected by some studies to call on 1.7 billion gallons per year additional from corn, stover, switchgrass, miscanthus, and other dedicated crops if we were to fulfill the 2022 RFS2 mandate. I don't need to go into all the other problems that the industry faces in the future. Many have been talked about already here today. In summary, biofuels and RFS2 faces enormous challenges in the future. It's likely that the cellulosic biofuels will not be met, not only for economic and technological reasons, but and the willingness to pay that I mentioned earlier, but the simple fact that the plants would have to be built now, and they're not on the horizon. Considerable water is needed. That's the main subject of this talk, and there are local water problems already associated with the ethanol production facilities. I should have put a recommendation slide, but I guess I would offer 3 recommendations. One is, from my perspective, we would not want to expand further. We're almost at the RFS2 mandate for 2015. We would never want to expand conventional biofuels due to their negative environmental consequences, even if Congress would ever get tempted in such a way. Number 2, I think we will need to delay and revise our cellulosic biofuel mandate. I don't know if EPA will do that year by year or how it will manifest itself, but definitely that needs to change. And 3, as we try to develop that cellulosic biofuel industry, we need to try to produce it as efficiently and environmentally sensitive as possible. Thanks very much.